Hello everybody, welcome to Algebra 1 release question number 43. It says Marcy has a total of 100 dimes and quarters. If the total value of the coins is $14.05, how many quarters does she have? And so could we kind of use a guess and check idea here? Yeah, they give us these answer choices, but again, just like the previous question, I said that I want you to be able to solve these problems without having solutions to look at. If they didn't give you these choices, you should still be able to figure out the answer to this problem. We should be able to do this in an algebraic way as well. So let's say that this, I think it makes sense to say that D is going to be my number of dimes, D for dimes, and let's go with Q for quarters. So let's let D equal dimes, Q equal quarters. If that's the case, you've got a total of 100 dimes and quarters put together. So you know that this would have to be one equation based on that fact. That D plus Q, number of dimes plus number of quarters, has to equal 100. And you also know that the number of dimes you have times 10 cents will give you the total amount that the number of dimes is worth. And so I'm going to use this without decimals. I'm just going to say 10D. So this is going to be in terms of cents now instead of dollars. 10 cents per dime plus how much per quarter? 25. 25 cents per quarter should equal not 14.05, that's in terms of dollars. Notice I'm doing these in terms of cents. It should equal 1,405 cents. And so this equation is true, so is this equation. We can use both of these equations together to solve for, what do we want? We want how many quarters. So we might as well try to get rid of the D first and solve for Q from there. It would just be extra work if we solve for Q first, or if we solve for D first and got Q from there. So let's get rid of the D's if at all possible. You could use substitution here. You could solve one side for D or Q and plug that in into the other one, but easier way, I think, linear combination. So let's take one of these equations or both and change them in some way. It looks like I don't want to change this bottom one, but remember I had said I want to solve for quarters. Might as well get rid of the D then. How could I get rid of the D with the 10D down here? If I had this one as negative 10D, that would cancel out with positive 10D. So if I multiply everything here times negative 10, that then will cancel out. So I have negative 10D minus 10Q equals 100 times negative 10 would be a negative 1,000. And no change here, so this would just be 10D plus 25Q equals 1405. Now putting these two equations together, this will cancel with this. I've got 15Q equals, this would be 405. Positive 1405 minus 1,000. Off the top of my head, sorry, I don't know what 405 divided by 15 is. No calculators allowed if you're taking the CST at least. We should be able to do this without a calculator regardless though. 15, how many times does that go into 40? Looks like 2 whole times. It would be 2 times 15, 30. We'd have 1 left over. And I know that 7 times 10 would be 70. 7 times 5 would be 35. If I put 70 and 35 together, I do in fact get what I see right there, 105. So no remainder. 27 is my value for Q when I divide 405 by 15. So 27 quarters. And just because I'm curious, let's find out how many dimes that would mean I would have. So if you had to solve this problem the entire way where you had to solve for both D and Q, I would take this, I would take this, these two equations, put them together. You'd have D plus Q is 27 now, equals 100. That means if you subtract 27, it looks like you're supposed to have 73 dimes. So if you weren't careful and you solved for D not realizing that you needed to solve for Q, you might mistakenly select D as your correct choice, but the correct choice, the actual correct choice, would be choice A, or should be choice A. You have 27 quarters and you have 73 dimes. Number 43, choice A.